Okay, this is the other one. Number of ways to get to places. This is not pathways, so I actually called this video number of roads, not pathways. However, I need you to understand that there's a variation of this, okay? So it could be number of doors, like I've seen that there are, 3 doors that connect room A to B and 4 doors that connect room B to C. How many ways can you get from A to C if you have to take a different door every time? Same idea. So in this case, I grabbed this, I don't know exactly how the question went, but I remember this is the one that came to mind. There was a question, you driving from A to B, and there's 1, 2, 3, 4, 5, 6 ways to get from A to B. And then there's 1, 2, 3, 4, 5 ways to get from B to C. This could be cities, this could be places in a city, it doesn't matter. And notice even further, if you zoom in even more, the solid lines represent busing, bus routes, and the dashed lines represent walking. This could be biking, you name it. So I'm adding a bit of a layer here, but if it just asks you how many ways can you get from A to C, so from A to C, you would just say, well, there's 6 here times 5 that connect me from B to C, so that's just 20 ways. If it asks me how many ways is it, like if you're busing, so if it's just asking from A to C, it's not asking you to go back to A, okay? So you have to read carefully. So that would just be, if it's busing only, there's 4 and 2, so it's just 4 times 2, there's 8 ways. How many ways to walk? There's 2 from A to B and 3 from B to C, so it's just 2 times 3, 6 ways. If it asks for what's the probability of someone busing, okay, you would just say, well, there's 8 ways to bus, and the total ways, if I didn't care about just the bus routes, is like in total 20 ways to get from A to C, right? Then I would just stack them and come up with a probability of busing from A to C. If it says probability of walking, I already figured that out. Here, there's 6 ways, so it'd be 6 over 20. Again, I will do this on the side here, A, B, C, D, E, F, right? How about A to C back to A? Like what if it asks you like a round trip? You didn't care in this case if it's busing or walking. So in that case, it's a little different, right? It's 6 times 5, and you got to go back, right? Because this gets you from A to B, this gets you from B to C, but then you need to go from C back to B and from B back to A. So there used to be 5 ways, now you're down to 4, right? This stretch here, you had 5, but when you come back, you only have 4. And then from B to A, you used to have 6, now you're down to 5. So that's how you would do it if it's a round trip, okay? So that's that. Another variation that I could think of is a maze has 3 entries and 5 exits. How many ways can you enter and exit if you use a different entry and exit? So it'd just be 3 times 5, okay? I didn't add that to this particular case, but the same thing would be like if you order pizzas. Like if you have, you have 3 different crusts, 3 different sauces, 4 different toppings, right? How many pizzas? It would be 3 times 3 times 4. Same idea, and then just watch, does it say or? How many pizzas with or without sauce? Then you need to actually do 2 different scenarios where it's with or without sauce. So if you want, I can gladly do that here. Pizzas, there's 3 crusts. Let's do 2 sauces and 4 toppings. It's a very low-end pizzeria, right? So how many ways? 3, 2, 4. That's 6 times 4 is 24 ways. It's 24 pizzas, different pizzas that can be ordered, right? What if it's with or without topping sauces? with or without sauces. What if it said that? Then you'd have to go 3, 2, 4, just like before. Or 3 and you omit the 2, you just go times 4. That'd be 12 and 24. That adds up to 36 total. So just read the question, and also make sure you have, just read carefully and look at the marks associated.